Are you struggling to bind an interface in Android data binding? It can be a tricky situation, especially when dealing with different objects. But don't worry, you're in the right place. Today, we're going to unravel this issue together. I totally understand your frustration. You have a fragment with text fields that should be filled by either an X1 object or an X2 object, both implementing the same interface. It sounds like a common challenge many developers face. Here's the specific situation we're addressing. One user asked how to use an interface for binding in their fragment. They mentioned that while using the IX object as a data binding reference, the method addOnPropertyChangedCallback in the base observable class is never called. Sound familiar? Let's dive into this. So what's happening here? When you use an interface for data binding, the binding library may not recognize changes in the properties of the objects implementing that interface. This can lead to the callback methods not being triggered as expected. And stick around. I have a crucial tip at the end that will help you effectively use interfaces in your data binding setup. To achieve data binding with an interface in Android, the user should first ensure that the interface IX object is properly implemented in both X1 object and X2 object. This means both classes must extend base observable and include the necessary getter and setter methods. Next, the user should modify the layout file to ensure that the data binding is set up correctly. The layout should include a variable for the IX object type, which allows binding to either X1 object or X2 object. In the fragment class, the user should ensure that they are setting the binding variable correctly. This involves creating an instance of either X1 object or X2 object and then binding it to the layout. Finally, the user should ensure that the properties in the IX object implementation are properly annotated with a bindable. This allows the data binding library to observe changes and update the UI accordingly. Fun fact, did you know that Android data binding was introduced to help developers write less boilerplate code? It's a powerful tool, but it can be tricky to master. Now, let's look at the answers provided by other users. An alternative approach suggested by another user is to use an abstract class instead of an interface. They propose creating an abstract class that extends base observable and includes abstract methods for setting and getting the name. Then you can implement this abstract class in your concrete classes, like X1 object, which will provide the actual implementation for the methods. Finally, you can create an instance of your concrete class, set the name, and bind it to your layout as before. That's it for that response. Let's explore another one. This user suggests that when declaring a variable in your layout file, you must use an actual object, not an interface. They explain that interfaces in Java are not objects, which limits what can be done in data binding. They recommend specifying the implementing class directly in the layout instead of the interface. If your base class has the necessary methods, you can use that instead. Additionally, they mention that you can bind directly to private member variables, which will still work with getters and setters. Another option is to create an adapter that handles the interface. Now, let's shift our focus to a different response. This user found that the issue with binding an interface in Android data binding stems from the requirement that each variable in the layout must implement the observable interface. They noted that if a variable is defined as a base class or interface that does not implement observable, it won't be observed. Let's take a look at another answer from another user. An alternative approach suggested by a user is to use the annotation at getBindable instead of just bindable inside your interface. They also recommend considering live data for better data binding practices. Now, let's dive into a different answer from another user. An alternative approach involves creating a custom binding adapter. This allows you to handle actions like clicks on an image view and control its visibility based on whether a handler is bound. In your layout, define a variable for the handler and set the image button's visibility to invisible by default. When the handler is set, the button becomes visible. Finally, in your component, you can assign the handler to execute specific actions, like dismissing a view model. Here's the tip I promised. Always ensure that your data binding variables are set to the correct object type. This small detail can make a huge difference in how your bindings work. And there you have it. With these steps, you should be able to bind your interface successfully in Android data binding. If you found this video helpful, please subscribe for more tips and tricks.